in today's lecture we are going to continue with the concepts of ellipse. So we will start from where we stopped in the last lecture and we will continue. We will learn some more concepts and properties and then we will solve some questions on chords. Okay. Shall we start? So here these were basic ideas of chords. We have learned all of them. We have also derived them. So when it comes to equations and properties, there are some standard equations of chords, tangents, normals. There are also properties of chords, tangents and normals. Every point needs to be proved and every property needs to be proved by yourself. So even if a teacher does it in the classroom, then it means teacher has skill, it does not mean that you have skill. So you need to develop your own skills, okay. So if teacher is able to do, it does not mean that you will be able to do, you need to practice all of them on your own. Now when we solve some questions directly come on the property or the formulae. So if you know the formulae, you can crack them, but in most of the time, especially from advanced point of view, most of the questions come from the fundamental ideas on which we build these properties. So if you prove the properties, you will be learning the techniques to solve the questions when questions come out of the box or when questions come differently in a complete different perspective, okay. So that is why I urge you to solve all properties and also to prove everything on your own and then proceed with the problem solving, okay. Shall we start now? So we have proved these yesterday in the last lecture. We proved this, we proved this, we proved this also. And also when chord passes through the focus, we proved this by substituting AE, 0. And when we take the other focus, which is minus AE, 0, there could be a different condition. I asked you to prove that. And then we learned the definition of diameter and we derived the equation of diameter if the slope is constant, which is m. We came till there. And then we were trying to understand these aspects which are the conjugate diameters. So let us try to prove them once and we will move on to the next concepts. So let us say there is one ellipse here. Okay, so let us say there is one ellipse here and correspondingly let us take one eccentric circle or auxiliary circle. So here this becomes our major axis. Having major axis as the diameter, if we draw a circle, it becomes our eccentric circle or auxiliary circle. So let us say this is our auxiliary circle, okay. So I am drawing this auxiliary circle for our reference because next two properties, in fact these three properties are based on the conjugate diameters only. So we need auxiliary circle for explanation. Now let us say we take two chords here, okay. So basically I am going to build chords based on the diameters that I am drawing for this circle. Okay, so this is one diameter. Now let us take another diameter here. Okay. Now corresponding to the points on the eccentric circle or auxiliary circle, if we drop, let us say these ordinates, we will get point here P, and let us say corresponding to this, if we drop one, we will get one corresponding point. Let us name this as P dash, and if we drop one, this point is let us say Q, and if we drop one, let us say this point is Q dash. Now when we join this P and P dash, we will get one line, and when we join this Q and Q dash, we will get another line. This is my setup, okay. So P dash is one diameter, Q dash is another diameter, okay. Now let us come back to this after we understand these. So we have the first property which is locus of the middle points of chords parallel to a given diameter will be another diameter which is called as the conjugate of the original diameter. So, here the situation will look something like this. Suppose let us say I have one ellipse, okay, and I have some chords here which are basically parallel chords. Now, locus of midpoints of all these parallel chords will be called as diameter. So, let us take the diameter here to be like this. This is the diameter. Let us name this as, let us say, D1. And parallel to this diameter, if I take chords, so let us draw them in a different line. Let us take green here. Okay. So, these chords are having same slope as the diameter D1. And if I join midpoints of all these green chords, then I will get another diameter. Okay. So, if I join midpoints of these, I will get another diameter, and I will let us say name this as D2. So, here D1 and D2 are called as conjugate diameters. So, if you observe closely, okay, so here there are too many lines which are confusing you. Okay. So, let me just draw them with single line like this. Okay. Okay. So, now here all chords that are parallel to D1 are having diameter D2. All chords that are parallel to D2 are having diameter D1. So, corresponding chords of D1 are parallel to D2, corresponding chords of D2 are parallel to D1. So, these kind of diameters are called as conjugate diameters. So, as I said earlier also in the last lecture, that diameters is in the concept of IIT, in the syllabus of IIT, but conjugate diameters are actually the borderline concept. So, it may come or may not come, but still we will discuss. Okay. So, now further, suppose if these blue chords are having, let us say, slope M1 and green chords are having, let us say, slope M2. Then what could be the relation between M1 and M2? Okay. So, we have seen that in the last lecture, we have seen that if the slope of chords is M, if slope of chords is M, if, then equation of diameter is y equal to minus b square x by a square m. This is what we have seen in the last lecture. So, if I take the slopes of chords as M1, then that means equation of diameter will be having M1 as slope. Now, we are claiming that the other chords of the other diameter, the chords of the corresponding diameter of the other diameter are going to be having slope M2, because those chords are parallel to the other diameter or this diameter. Okay. So, this equation of line will give this slope minus b square by a square into M1. This must be equal to M2. Okay. So, all the chords of slope M1 are giving diameter, which diameter? D1. All chords of slope having slope M2 are giving the diameter D2. So, then slope of this must be equal to this. So, this way if we observe, we can say that M1 into M2 must be always equal to minus b square by a square. So, this is the property of the conjugate diameters. So, here if we observe, we have understood the meaning of conjugate diameters geometrically here, and then we have also proved this property directly. Okay. So, if M1, M2 are slopes of the diameters, then M1 into M2 must be minus b square by a square. Okay. So, now after this, the other property says that eccentric angles of ends of two conjugate diameters differ by pi by 2. So, how do we prove this? Okay. Suppose if we look at this diagram and let us say I take this angle as alpha and I take this angle as beta, okay, and PP dash is one diameter, QQ dash is other diameter. So, M1, that is the slope of one diameter, becomes tan alpha, and M2, that is the slope of the other diameter, becomes tan beta. Okay. So, these alpha and beta are not eccentric angles, they are basically the angles made by these diameters with x-axis. Now, if this point is, let us say, P1 and if this point is P1 dash. So, P1 dash is the corresponding diameter on auxiliary circle for PP dash. Now, if we take that angle as, let us say, theta 1 and if we take this angle as theta 2. So, we can say that the point P is having coordinates a cos theta 1, comma b sin theta 1. Similarly, point Q is having coordinates a cos theta 2, comma b sin theta 2. Okay. Now, we know that this alpha and theta are directly related with this property that tan alpha is equal to b by a into tan theta 1. Similarly, tan beta will be equal to b by a into tan theta 2. We have learned this in the second lecture where we understood the auxiliary circle. Now, for conjugate diameters, M1, M2 must be equal to minus b square by a square. So, if I apply it here, M1 into M2 must be equal to minus b square by a square. Now, what is M1? M1 is basically tan alpha, M2 is basically tan beta. So, the product of these two must be equal to minus b square by a square, but M1 is nothing but tan alpha, which is nothing but b by a into tan theta 1. So, here we can write b by a into tan theta 1 into b by a into tan theta 2. This must be equal to minus b square by a square. So, which means this b square by a square will get cancelled and we are basically getting tan theta 1 into tan theta 2 equal to minus 1. So, what is the meaning of this? This means the difference between this theta 1 and theta 2 must be 90 degrees. Okay. So, why is this 90? Because you observe that tan A into tan B, if that is equal to minus 1, that means those two lines are basically perpendicular. Okay. So, that means the corresponding diameters on the eccentric circle or the auxiliary circle must be at right angles, which also means that theta 2 must be equal to theta 1 plus pi by 2. Okay. Or the other way around. Suppose let us say if I take this corresponding eccentric angle of this q dash as let us say a cos theta 3 comma b sin theta 3, then difference between theta 1 and theta 3 also must be pi by 2. So, that order that you need to take based on the sign convention, whether it is theta 1 minus theta 3 or theta 3 minus theta 1, that should be taken using the sign convention. Okay. So, this way we can solve this problem and prove this property. Okay. So, I hope you have liked this sign analysis. Now, quickly make a note of this. Okay. So, basically we have proved all three of them in one single go. Okay. So, what is conjugate diameters, what is the property and what is the difference of eccentric angles of these conjugate diameters. So, we have learned this. Now, we will move on to the next property. Now, this property has been very common property. We have learned similar property in parabola also. Now similarly for ellipse also we can prove this. You can either take the points as a cos theta, b sin theta and start with it, or you can also take points as h comma k and prove it. Okay. So this I am leaving this to you, you try to prove this at your home, and will if you are not able to prove it, you can post it on the app, we will also prove it, but we will use it in solving problems today. Okay. So now shall we start problems? So with this we complete all ideas of chords, and now we will proceed with the problems. Okay. Okay. Next. So let us say this is our first problem. So where PS P dash is a focal chord of the ellipse. So here if we simplify this ellipse, we are getting x square by 25 plus y square by 16 equal to 1. So which will give me a equal to 5, b equal to 4. Now SP is given as 4, SP means focal length. So suppose let us say I have this ellipse and this is my let us say focus S. So this becomes one focal chord, let us take this as P and let us take this as P dash. And we have to find S dash P dash. So if there is another focus which is S dash, we are interested in this length. But we know that SP and SP dash are connected with this property, So using this we can calculate SP dash, and also P dash S plus P dash S dash must be equal to 2A. So using this we can calculate P dash S dash. So let us just do that. So here PS is given as 4 units and we want to find out this length. So let us say if I take it as small l, so I can say that 1 by 4 plus 1 by L, this must be equal to 2 by half of the lattice rectum, that will be b square by a. Now if we simplify this, what do we get? 1 by L equal to 2 into a by b square. What is a? 5 here, by b square is how much? 16 minus 1 by 4. So if we simplify this, what do we get? 5 by 8 minus 2 by 8, which will give me 3 by 8. So basically we are getting L equal to 8 by 3. Okay. So now we know that we want to calculate which one? S dash P dash. So S dash P dash equal to 2A minus P dash S, and P dash S we got as 8 by 3 and 2A will be 10. So 10 minus 8 by 3 will give us the required value. So 10 into 3 here is 30, 30 minus 8 is 22. So this value must be 22 by 3. So required length is 22 by 3. So here we have used this property and calculated. If we are not using properties, then these questions may become very lengthy. Okay, come on, make a note of this. Now let us go to the next problem. So here two lines are given as two conjugate diameters. Then we are asked to find eccentricity, which is E. So how do we do this? We have the direct property of conjugate diameters, we will use it and prove it. So suppose let us say we take the slope of this as m1, which is 2. We take the slope of this as m2, which is minus 1 by 3, and then because these are conjugate diameters, m1 into m2 must be equal to minus b square by a square. So if I apply this here, so what do I get? 2 into minus 1 by 3 equal to minus b square by a square, minus minus get cancelled, and we are getting b square by a square equal to 2 by 3. Now we know that E has a standard formula which is root of 1 minus b square by a square, which can be written as root of 1 minus 2 by 3, which is same as root of 1 by 3, which is 1 by root 3. So, value of E is 1 by root 3. So, here also we directly use the properties and solved it. Okay. Come on, make a note of this also. Okay. Next problem. So, here find the equation of the diameter of the corresponding equation of the diameter corresponding to the system of chords parallel to this. So, here there are two styles of solving it. One is, let us assume that this is one second degree curve and let us apply the definition of diameter directly. Okay. So, from here we have to use this line as a reference line which is parallel to the system of chords. So, from here we will get the slope as 2 units. Okay. So, here slope is equal to 2 units and we are going to use this slope. So, if I try to directly calculate the diameter, what is the process? We first assume a locus point and then we use equation of diameter as S1 equal to S11 and then we will try to compare the slopes with this. Okay. So, let us just start it like this. So, let h comma k be the locus point. So, this is the midpoint of the chords. So, that means equation of chord will be, equation of chord can be written as S1 equal to S11. So, which will give me 2 into xh plus 3 into yk minus 4 into x plus h minus 9 into y plus k plus 35 is equal to, now full substitution of the point. So, which will give me 2h square plus 3k square minus 8h minus 18k plus 35. Now, if you notice, this term is a constant, this is a constant, this is a constant, all these terms are constants. So, they will not play any role in our problem because our comparison is only with the slope. So, now we are not interested in these constant terms at all, we are interested only in x term and y term. So, let me extract only the terms that I want. So, if I take x common here, so what do I get? 2h here and minus 4 here. If I take y common, 3k here minus 9 here, okay, and whatever remains is my constant c. I do not care what that constant is, I do not have to simplify. Now, this is the assuming that h comma k is the midpoint, I have got this as the chord. Now, this chord must be parallel to that. So, that means I have to put the slope to be equal to 2. So, if I equate the slope to 2, what do I get? 2h minus 4 by 3k minus 9 into minus sign, this must be equal to 2. Now, let me simplify this. Here 1 2 gets common and you can cancel it out. So, we will basically get h minus 2 here and this I am sending there and again bringing it here. So, it becomes plus 3k minus 9 equal to 0. So, here we are basically getting x plus 3y minus 11 equal to 0 as the equation of the diameter. So, this is the result that we got after we followed the standard method of finding the diameter. Okay. So, please copy this and after that we will do it in a different way. So, the next one, suppose if, okay sorry, we are doing it by the next method, second method. So, the second method goes like this. We take the equation and we simplify it. So, here it becomes 2x square plus 3y square minus 8x, okay, minus 18y plus 35. So, what I will do here is I will try to convert this into the standard form of the ellipse, okay. Because xy term is absent, this could be converted. Or you can also view this as if I am applying simply the completing square method and simplifying this. So, what do I get here? So, if I take all x terms and take 2 common from x terms, I am getting x square minus 4x here. Similarly, from here if I am taking 3 common, I am taking y square minus 6y. Okay. Now, the constant term is 35 here, which I will just leave it there. This is equal to 0. Now, to complete the square here, what is the term that I must be adding? I must add 4 here to complete the square. So, extra how much did I add? 2 into 4, 8 I added. So, I have to balance it by subtracting 8. Similarly, for the second term, to complete the square here, I need to add 9 here. So, if I add 9, how much do I have to balance? I have to balance minus 27 here. Now, if we simplify, what do we get here? 2 into x minus 2 whole square plus 3 into y minus 3 whole square, and here this term is coming out to be 0. So, we are getting equal to 0 here. So, when we simplify this, we got sum of two perfect squares equal to 0. Now, this is possible only when both squares are equal to 0. So, that means basically we are getting a point which is 2, 3. So, this equation does not represent an ellipse, it represents a point. If it is a point, how can we get a diameter? It is not possible. But if you are treating the point as a curve, the diameter also must be a point. So, whatever is the equation that we got earlier, this must be satisfied with this point. What is the point we got? 2, 3. If we substitute the point here, 2, 3, so 2 plus 3 into 3, which is 9, that is coming out to be 11, so it is satisfied. So, even though we did not get any curve, we got a line which is passing through that point. Okay. So, here it is also important to analyze the condition here. Okay. So, whenever you get any question like this, before you proceed like this, you better analyze what exactly is that curve. Okay. Now, this is one idea. Now, the next is, suppose let us say this 0 did not come, let us say you got a constant there, then how to proceed? If it was a constant, that I will do in the red. Okay. So, suppose let us say after we simplify it, we got an equation like this, x minus h whole square by a square plus y minus k whole square by b square is equal to 1. We got an equation like this. Now, for standard ellipse, for this ellipse, the equation of diameter that we got is like this, y equal to minus b square x by a square m, where m is the slope of the chords. So, now when we shift this diameter along with the ellipse, because what is the connection between this ellipse and that ellipse? That is shifted version of this ellipse. So, when I directly use the shifting idea, so the correspondingly diameter also must get the similar algebraic analysis. So, here it looks like y minus k equal to minus b square into x minus h by a square into m. Okay. So, now when we simplify this, we will get the required equation of diameter. So, this could be a method. If you are following this method, if you are following the completing square method, and if this right hand side was not 0. Okay. So, basically here we have analyzed it completely using this completing square method. Okay. So, I hope you are liking these questions, make a copy of them. Okay. So, now can we proceed? Okay. So, next problem. Suppose if O is the center, F is the focus of an ellipse whose major and minor axes are AB and CD. The diameter of the circle inscribed in triangle OCF is 2 and OF is given as 6. Find AB into CD. So, let us take one ellipse here. Okay. So, we will take the ellipse in the next page. So, let us say we have taken one big ellipse here. Okay. So, when I am joining these ends, I am getting the major axis and this is going to be the minor axis. Let us say this is my focus F and this is the center O. What else is given? AB and CD are the major and minor axis. So, let us take this as A, this as B, this as C, this as D. If I take AB as 2A, if I take CD as 2B, and we have to find out AB into CD, which is basically same as 2A into 2B. Okay. So, we have to find A and B. And what else is the information given? When we join C and F, there is one triangle formed and in circle of that triangle is given as diameter. Okay. So, the information about in circle is given as diameter. So, let us take one circle here. Okay. So, let us say this is my in circle. Now, if I join the center with the points of tangency here, now they become the radii and tangent is always perpendicular to the radius. This is 1 unit, this is also 1 unit. Because this OF and OC are already perpendicular, that will make this a square. So, hence these lengths also become 1 units. Okay. Because diameter is 2, I took the radius as 1. Okay. So, now let me see what else is the information given. OF is given as 6. Okay. So, that means this entire distance is given as the 6 units. So, this distance can be taken as 5 units because 5 plus 1 is going to be 6. Okay. Okay. Because this is tangent drawn from F and this length is also same as this because those are the tangents drawn from the same point. So, if this is 5 units, this also becomes 5 units. If I take this total length of semi minor axis as B, then this length will become B minus 1. If this is B minus 1, then this length is also equal to that. So, this becomes B minus 1. So, basically using the pure geometry, I have simplified this into this form. Now, in this triangle, if I apply Pythagoras theorem, I can calculate B directly. So, here we can say that 6 square plus B square is going to be B minus 1 plus 5 whole square, which is basically same as B plus 4 whole square. Now, if I simplify it, what do I get? So, I will get 36 plus B square is equal to B square plus 16 plus 8B. Now, here B square is getting cancelled and I can get B directly from here. So, 36 minus 16 is 20. So, 8B is equal to 20. So, B will be equal to 20 by 8, which is same as 5 by 2. Okay. So, B is equal to 5 by 2, which means 2B is equal to 5 units. So we got one information here. Now we need A. We got 2B, that's fine. We need now 2A. So how do we find A from here? There is one more information which we have not used fully, which is this AE. Because distance from center to focus is AE and AE must be equal to 6. So if AE is 6, then we can say that A square into E square is nothing but A square minus B square. So which means here 6 square is equal to A square minus what is the B given? B is 5 by 2 whole square. Okay, this is all fine. So A square can be directly calculated from here. So A square is going to be 36 plus 25 by 4. Now 36 into 4 is 144 plus 25 is 169 by 4, which is same as 13 by 2 whole square. So from here I am getting A equal to 13 by 2, which will mean that 2A is equal to 13. So what will be AB into CD here? AB into CD is going to be basically 13 into 5, which is 65. So this way we can calculate the required value. Okay. So this way we can solve this problem. So if you look at this, we have used only pure geometry to solve this problem. Okay. So come on, make a note of this. Okay. Next, can we proceed to the next problem? So here PQ is a common tangent of these two and RS is a focal chord of ellipse drawn parallel to PQ meeting the circle in RNS. Basically here information about common tangent is required to solve this. So we will deal with it after we learn the concept of tangents. But still in today's lecture, if we finish all other questions that we have taken, then I will solve this. If not, we will take this up in the tangents lecture. Okay. So let us solve this problem. Find the length of the longest chord of the curve. So here curve is given. Now because we are solving this in the chapter ellipse, we know that it is going to be ellipse, but we need to verify if it is an ellipse or not if it comes in the exam, because blindly attacking it is going to confuse you. Okay. But in general, you can take it as a thumb rule that ax square plus 2hxy plus by square plus c equal to 0 represents a central conic. Okay. So this represents a central conic, that means it has center. What are the central conics? Ellipse and hyperbola. Okay. But we will solve this assuming that it is not an ellipse or anything. So what is the procedure? Our procedure is first to shortlist A, B, C all the values. So A is 1 here, 2h is 1, B is 1, G is 0, F is 0 and C is minus 1. Okay. So now we have all of them. We need to verify if delta is 0 or not. Okay. So what is delta? All hot girls having boyfriends go for cinema. So we will just verify if it is 0 or not. In this particular case, it has to be coming not equal to 0. So hence it is not pair of straight lines. In this particular situation, it will not be equal to 0. Okay. Now after this, we need to verify if h square minus ab is less than 0 or not. So here it comes out to be 1 by 2 whole square minus 1 into 1, which is generally less than 0. So we can directly proceed with the problem solving. Now to solve the problem, what is the idea? We know that this is going to be ellipse. Till now we have confirmed that it is ellipse. Now what is the next procedure? Because G and F are zeros, that means because x and y terms are absent, because linear terms are absent, the center of this conic is going to be origin. Now we have understood that the center is going to be origin, but major axis and minor axis are not parallel to coordinate axis. So it must be a tilted ellipse. So we can take one tilted ellipse here. Now let us say this is the center, which is the origin here, and this is our y axis. Okay. Now any point on this ellipse can be joined as a radius vector. So if we apply little bit of polar coordinates, okay. So let us say I take this radius as r, I take this angle made by this vector with the x axis as theta, then coordinates of this point will become r cos theta comma r sin theta. So let us imagine that r is varying and theta is also varying. So theta can vary from 0 to 360 degrees and r can vary from shortest distance to farthest distance, greatest distance. So now where do we get the shortest and greatest distance here? So from here if I join this point, I will get the greatest distance, which is the r max, and if I join this point, I will get the shortest distance, which is r min. Okay. Now if you understand this with the symmetry and the diagram of the ellipse, you will get this r max to be equal to a, which is semi-major axis, and r min to be equal to b, which is the semi-minor axis. Now we got semi-major axis, semi-minor axis geometrically here. Okay. So what it means is the farthest point from the center must be one end of the major axis, the closest point from the center must be one end of the minor axis. That is the whole idea. So how do we interpret this algebraically? As I said in the earlier lecture also, every step we are writing in the algebra has a meaning in geometry. Every meaning in the geometry has a form in algebra. So let me just take this to complete algebra. So what I will do here is, I put r cos theta comma r sin theta in this equation for x and y and analyze the value of r based on whatever the situation is. Okay. So let me just substitute there. So we got r cos theta whole square plus r cos theta into r sin theta plus r sin theta whole square is equal to 1. So basically for x I substituted r cos theta, for y I substituted r sin theta. Now if I simplify this, what do I get? Cos square theta here plus sin square theta plus cos theta into sin theta equal to 1. We know that cos square plus sin square theta is going to be 1 unit, and we know that cos theta into sin theta can be simplified using this idea, because 2 sin theta cos theta is going to be sin 2 theta. So I can simplify this into sin 2 theta. So it becomes r square into 1 plus sin 2 theta by 2 is equal to 1. So r square can be written as 1 by 1 plus 1 by 2 into sin 2 theta. So here if we check the RHS, variable is there only in the denominator. Now what am I interested in? I am interested in the longest chord. Longest chord is the major axis. So basically I am interested in r max. If I can get the r max, by doubling it I will get the 2a, which is the major axis, length of the major axis, which is the longest chord. So now to get r max, I will focus on r square max. So r square is maximum when here the denominator is minimum. When denominator is maximum, I will get the r minimum, that means overall value will be minimum. So now I want the denominator to be minimum to get the r max. What is the minimum value of this? For that we need to understand the values of sin 2 theta. And we know that sin 2 theta belongs to always minus 1 to 1. if sin 2 theta is belonging to minus 1 to 1, what is the minimum value here? Minus 1. So, when I put minus 1 here, I can say that R max whole square is going to be 1 by 1 plus 1 by 2 into minus 1, which is same as 1 by 1 minus 1 by 2, which is same as 1 by 1 by 2. So, here we will get 2. Okay. So, R max must be equal to root of 2. R max is same as A, which is same as root of 2. That means, what is the major axis here? It is going to be 2 root 2. So, that means what is the longest chord? The length of longest chord is 2 root 2. So, this way we can solve this problem. Okay. So, if you have understood the idea here, we have taken help of r cos theta, r sin theta to solve this problem. Okay. Come on, make a note of this. And this page also. Okay, next, PQRS are two conjugate diameters of the ellipse. It is given. If the eccentric angle of P is theta, find the area of the parallelogram found by the tangents at PQRS. Okay. So, let us draw the diagram first. So, let us say there is one ellipse here. Okay, so let us say there is one ellipse here and we got one major axis here and minor axis here. Okay, so these are not that important. Here the conjugate diameters are more important. Okay. So, let us say there is one diameter here. Okay. And there is another diameter here. So, of course, these two diameters are not perpendicular. Okay. So, now at the ends of these two diameters, there are total 4 tangents. So, here there is one tangent like this, and here also there is one tangent like this. Okay. So, these two lines are parallel. Okay. So, these two lines are parallel and also here there is one tangent and here also there is another tangent. Okay. So, let us take this tangent as the point here. Okay. And we want to find the area of this entire parallelogram, which is drawn by red lines. Suppose let us say if I take this point as A cos alpha, B sin alpha. Now, we know that conjugate diameters differ by eccentric angle of pi by 2. So, that means this point, let us say this is P, this is Q, this is P dash, this is Q dash, and we can take this parallelogram as L, M, N and O or K. O generally we use for the origin. So, let us take this as K. Okay. So, it is KLMN. We want to find the area of the diagram KLMN, and here we have PP dash and QQ dash as the conjugate diameters. So, if P is taken like this, then Q can be taken with a difference of angle which is pi by 2. So, for this, for Q, the angle can be taken as 90 plus alpha. So, it becomes A into cos of alpha plus pi by 2, comma B into sin of alpha plus pi by 2. So, this means it becomes minus A sin alpha, comma B cos alpha. This is sin 90 plus theta and cos 90 plus theta. There is this parallelogram here. We got the points P and Q. Okay. So, then how to proceed with the overall area? So, here if you observe, this PP dash line is passing through the origin and QQ dash is bisected exactly at the origin. So, because this line is parallel to this line and also parallel here and it is bisecting the chord, it is going to bisect this side and this side also, which means P must be the midpoint of L and K. Similarly, P dash must be the midpoint of M and N. Okay. So, this means that this PP dash is exactly passing through the midpoints of this chord and also midpoint of this side and also midpoint of this side. Similarly, QQ dash is going to pass through the midpoints. So, now when we join these lines, we can conclude one idea, simple idea here, that area of the parallelogram KLMN is going to be equal to 4 into area of the parallelogram OPLQ. We concluded this based on the symmetry in the diagram. Okay. Now, the next stage, if we check this parallelogram, because these two are parallel and equal and these two are also parallel and equal, this PQ becomes the diagonal of this smaller parallelogram. So, we know the properties of parallelogram that diagonal bisects the area. So, we can further say that this is going to be further 2 into the area of triangle OPQ. Okay. So, now finding area of triangle is simple. We can find the area of triangle OPQ in a simple way, but we do not use the half base into height, we will be using the coordinates here. We have the coordinates of P, coordinates of Q, and also we have the coordinates of the center, which is the origin. So, we can directly use it. So, how do we do that? This is equal to half into determinant of 1 1 1 x1 y1, for this I have taken center as the coordinates. Next, x2 y2, which is a cos alpha into and b sin alpha. For q, I can take minus a sin alpha and b cos alpha. Now, finding this determinant is very silly. So, you can directly write it. So, 8 into 1 by 2 into what are we getting here? AB cos square alpha plus AB sin square alpha, because we know that cos square alpha plus sin square alpha is 1. So, we can straight away say that it is going to be 4AB. So, that is the area of this parallelogram. Now, in some cases, suppose in the exam you get any question of this kind and in the options the answer is going to be constant in terms of A and B. Of course, A and B are constants here. So, then you can also solve this problem for trivial cases. For example, let us say I have taken this ellipse, okay, and this is the tangent at the vertex and these are the tangents at the ends of minor axis. All of them will form a rectangle. So, this side will be of the length 2b, this side will be of the length 2a. So, area of this rectangle is going to be 4ab. So, here you can treat major axis and minor axis also as diameters which are conjugate. Of course, for every curve, for every ellipse, major axis and minor axis are also conjugate diameters. So, for these conjugate diameters, if the parallelogram has area 4ab, and if we know that for any conjugate diameters the area is going to be constant, so we can just solve it for this and use it for the other. Okay. So, but this sneaky technique is for the exam, but not for the classroom. So, in our virtual classroom also you are here to learn techniques. So, focus mainly on learning techniques than the learning shortcuts or tricks. Okay. So, we stop here for today's lecture. We will meet again in the next lecture with few more concepts and problem solving skills. Until then, have a great learning day. Learning shall never stop.